Lesson 87, we're going to look at similarity ratios for similar figures. Now, just a reminder, what similar means is the same shape but different size. So right here we have two squares. One is smaller, one is larger. They're both a square, but they are different size squares. So therefore they are similar. And what 87-1 theorem says is if two similar figures have a scale factor of A to B, this could be anything. This could be a 1 to 2 ratio, all right? It could be a 2 to 7 ratio, whatever A and B is, then the ratio of their perimeters would also have an A to B ratio. So, say this had say this was, actually, I'll tell you what, we'll look at example 2 and just start there. We'll look at example 2. Example 2 wants us to find the perimeter of these two figures. And hopefully you can get the big picture here, and then it'll make this little thing make sense. So let's just try to do example 2. Example 2 gives us two similar rectangles, and it shows us the length of one side here is 4x, the length of this side here is 12x, and then it actually gives us the perimeter of this one is 50. So going back to theorem 87-1, for any ratio A to B, all right, so what's our A to B ratio here? Well, here it would be 4 to 12. That would be our A to B ratio. So I'm going to put 4 over 12. Actually, I'm going to go ahead and reduce that to 1 over 3. 1 over 3. Now, so for the side lengths that have an A to B ratio, the perimeter also has an A to B ratio. Well, in this case, it gives us the perimeter of the smaller rectangle as 50. All right? So we can plug in 50 to our smaller rectangle. And then we would be looking for the perimeter of this rectangle. We can't add all the sides because we don't know all the sides. We only know 4x, and it's not a square. I'm trying to make sure it's worded properly. So for a ratio of A to B, okay, think of this as one side, okay, 4x over 12x. The ratios of the perimeters are also A to B. Hopefully you get the concept. I feel like I didn't explain that extremely well, but that is the concept. And so then we solve. We cross multiply. 50 times 3 is 150. 1 times x is x. So the perimeter of the big rectangle is 150. Notice 50 over 150 has the same 1 to 3 ratio. And that's what I am trying to say, and the ratio of the side lengths of A over B is equal to the perimeter A over B. So hopefully that made a little sense. Now let's look at the area. We're going to look at example 3. Okay, let me draw this triangle here. Example 3, it says, if two triangles have a similarity ratio of 2 to 5, and let me draw this. Wow, that was a terrible triangle. Okay, little triangle, big triangle, height of 40, base of 25. And it says they have a 2 to 5 ratio. Okay? So it wants to determine the ratio of the areas and the area of the smaller triangle. Because, well, one thing we can already know is the area of this triangle. Because we have the height and the base. So area equals 1/2 of 40 times 25. So that would be 20 times 25, giving us 500. So the area of this one is 500. Now, this is our ratio. So we already did perimeter. We did that in example 2. Area, what it says is if you have, for any A to B ratio, the ratio of their areas would be A squared to B squared. So rather than just saying, if I said 2 over 5 equals X, I'll put area over 500, well, that would not be correct because this is the perimeter ratio. This would be A over B equals A over B. So what I need to do is square my ratio, because this is not just A over B, it's A squared over B squared. So our ratio would actually be A squared 4 over B squared 25. 2 squared is 4, 5 squared 25, and now we can solve for our area of the smaller triangle. So I do cross multiplying, that's 2,000 equals 25A, and when I solve, I would get 80 inches squared, or whatever it is, centimeters squared. But that is how I do my ratios for perimeters and areas.